They said the 3-inch 1S drone has no business flying long range. Yeah, I took it 4 kilometers out and still plan to go further. Join me on the build and the battery comparison. Hey everyone, thanks to popular demand, I decided to put up a video about the small Ranger build, how I built it and what's the actual performance. But not only that, I was really invested in actually testing its performance on different batteries, predominantly 18650 Ampace JP30, that's in the new withdrawn Nitro Nectar Gold or something like that, and 21700 battery that I use daily for this build. So basically, as you can see, most of the build will be shown within this. So the build is based, it's quite simple actually. It's based on the FPV Matrix Stream 1 HD from the Meteor 75 Pro HD quad. It's a great little board that actually has an onboard back that enables you to go really low with the voltage, and you can push it, especially in these kinds of builds, from my experience, the most. On top of it, I went digital, DJI O4 lite with some antenna mods. Basically, how it performed for me was great because I didn't want to go analog. Based on DJI O4 performance and the range that people were representing, I was blown away, and I said, okay, going all in. For the views, I mean, if you're already gonna be in the goggles for 20 minutes, you should see something nice. So I went with a Flyvo O4 wide-angle lens kit with some ND filters to potentially reduce some of the jitters that the gyro can demonstrate. The motors, the motors were really a selection process. Basically, long story short, 12, 0, 2.5, 11, 500 kV motors for me turned out to be the best option because they don't produce so much sag, but in the thrust area they can provide sufficient thrust to go far and to go high. Regarding the props, I think I've tried all of the 3-inch props on the planet that are available for this motor dimension, and finally, after lots of testing, I settled on 3020 Gemfan props. That means it's like 3-inch and with 2.0 inch pitch. I went lower, didn't work out. I tried bi-blades, didn't work out. They're actually kind of pain to tune, and 3020 really showed like they perform good for me. Regarding the radio link, this was also one of the pain points I tried to address. I tested 915 megahertz, I tested 2.4, and of course I went Gemini initially, but it didn't work out for me. To be able to test the 915 and 2.4 to switch between them, I used the GEP-RC Gemini switchable receiver, but it was only one antenna, and after some exploration I went with the True Diversity Radio Master RP4TD 2.4 True Diversity RX. This one performs like the best. It's actually the best. No issues with range regarding this build now, so I can go really far. Regarding the VTX antenna, I've been testing a lot in this area, and for me, the best one, the one that performs the best is the Happy Models 5.8 LHCP VTX antenna, lollipop style, and it works wonders. Like kilometers out, no issues. It's like just like on a big quad. And regarding the GPS, Flyvo GOKU V3 Nano. And regarding the frame, that's the interesting part. Regarding the frames, I went with Pirate Frame Gems 3-inch and half of a Crux frame, and you're gonna As you've noticed here, maybe in the build video, I used one half of this frame to mount the GPS in the back due to the issues I had previously, where after some time it would just become too saturated with DJI O4 signal and would perform really, really bad. Now, on this very small Nano, on this very small Nano GPS, as you can see in the video, I rarely have under 20 satellites. And for the test, I decided to do a side-by-side comparison. As you will see, I flew the same two setups for a distance that I would usually go for. My end goal with this build with the 1S is to go over 5 kilometers and back, so that's like 10 kilometers plus total of flight, and for this you need a lot of capacity. You don't need acro, you don't need maneuverability, you need it to be able to stand in the air and to resist wind in some sort, and if possible. What you're looking at now is the two flights in parallel. They were done day by day because I swapped the battery mount in the afternoon and went back tomorrow, same time of day, same weather conditions, same everything, and went for the same run. Initially, on your left side, as you know, you can see the 18650, and on the right side you can see the 21700 battery performance. The main difference between these two footages is that I used manual settings on the left side and auto settings on the right side, but that's not the point here. The point is to go far and as far and as out as you can. During the flight, there were no major discrepancies. Just one on a side note, what you see on the 18650 is you will see later after this flight finishes. Before this flight, I had a short flight where I wanted to start, but the DJI O4 actually was fluctuating. I landed and just pressed the battery a bit more. There I landed and actually just pressed the antenna to the IEO just a bit more because it was creating me problems. After that I fixed it with some B7000, and after that I don't have the ideas. So basically, last couple of months have been really intense for me with this build. I've been tinkering with building a long-range toothpick micro drone based on the Suka from the fellow YouTuber. I'm gonna link him below because he got me into this. It was an inspiration, but after I went into this, I really went heads, balls deep into this one. I really went deep. Initially I went into it for the fun of building, but it seemed budget compared to all of the long-range rigs. And it's such a versatile platform. It can be a silent park flyer, can be a digital setup, so that you can record something on your travels. Very, very inconspicuous, very silent, very stealth, and it travels great with me. It travels with me everywhere I go now. There are a couple of setups I keep it in, so with the small lipos, 500, 600 mAh, or with these really big 5,000 milliamp hours or 3,000 milliamp hours that I'm testing here. So basically, yeah, I tried more than a couple of frames for this build. Really, I think 5 or 6, and I finally settled on Pirate Frames gems because it is thick. It's 2.5 millimeters thick, but only 7.3 grams. It's a really good quality carbon. There's no vibration on it. You cannot almost bend it at all. It's really a good frame for any application, but for me it was great because heavy battery as this really induces a lot of stress on the motors. You have to, you can see the throttle curve on the right. It's always a plus 60 or something like that when you really try to go with it further. I also tested a bunch of VTX antennas, and I settled on the Lollipop style from the Happy model that I mentioned, and this was a Crux of its own. because initially it was the biggest pain point for me. I would go out and just lose video after a kilometer or two. But it's not only about the antenna, it's the antenna placement. It should always be really on the top of your build, high above that. It is facing you, the side of it that is facing you, no matter how the drone is oriented. And now in this setup it works wonders. So initially, I was planning to just go for distance, but then on my first reel that really picked up was the climb to the GOKU mountain. It was a 1,000 meter climb with maybe 2,000 meters distance gained. It was really, I didn't know what I was getting into. I just sent it, and when I got there, I was thrown around by the wind. And it was a really fun flight, but my GPS was dying when I turned back, and I think that when the DJI really blasted its magic into it, because the GPS was initially mounted on the side of one of the legs of the drone, and it didn't work out. I really changed a lot of configurations for it, but finally, and even wanted to replace it. I purchased a bigger one and tried. And I was really considering, okay, I'm going to replace it with a really big one, disregarding the weight penalty, because I wanted to have an accurate reading and safe return to home in case I lose video, like around a few kilometers out. But basically, when I added this other frame, half of the Crux frame, that was my initial frame that I started with, a lot of things changed. So the vibrations are smaller. I can really pinpoint the center of gravity now with the ballast being in the back from the GPS in the additional frame, so I can move the battery a bit forward. And the signal improved drastically. It's like really, really good now. I have like 25 plus sometimes satellites continuously during the flights, and I can really monitor its performance, the distance traveled. Of course, you can see not only your speed, but it's really important to have a reliable and optimally working GPS in case you really need to hit that panic switch and initiate return to home. This one tested jillions of times now. It really, really works great. But within this process, I learned a lot about drones in general, not only about creating optimal weighted long-range rigs, but how do these machines perform in some edge cases. For example, when you climb with a heavy drone, there's the penalty of the air thickness. So the higher you go, the air becomes thinner. And for example, you should add 10% throttle to your hover values with each 1,000 meters that you climb. It's a rough estimate, but when you climb higher on the 1,000 meters mark, it's just you lose 10% of thrust with each 1,000 meters that you climb, and it's very, very visible when you're high up in the mountains, and you want to get over that ridge, and it just won't. I had a situation with a small Ranger when I tested the higher kV motors that were inducing a lot of sag. So I tried, tri-blades, bi-blades and everything, but I would come to this ridge that I was usually climbing. And when I would get, to go over the ridge, it wouldn't go. My throttle was at almost 100% and it wouldn't go. Of course, there was some wind, but two things happened. Like higher kV motors draw more current. You lose more voltage, and subsequently your kV times the available voltage is the RPM your motors can spin, and you just couldn't and I just couldn't push it over the edge. It was really, really frustrating to me. I didn't know, so I did everything. I replaced the motors, I tinkered with the prop size and prop pitch, and it didn't work. I was really like, what did I do now? How can it not go above this ridge? And then I learned another thing. You cannot climb as steep as you like. So I wanted to go high, but I didn't have to come that close to the mountain. When I, moved my lift-off location a kilometer back and went with a more gradual climb to the 1,000-meter, it went no issues. It just went. It was so cool to see. So there's also like a lot of things. I mean, to go from 15 to 1,250 meters is a lot, and to see that sag when you get there is really like panic-inducing. So you climb from 15 to 1,250 meters, and you lose like 12% thrust, and you're already almost maxed. Specifically, when I had those 15 kV motors. So I would already be, losing a lot of thrust due to sag, and you climb there and you lose another 10%, and you already like kept your motors to throttle output limit to 85%. You are basically just hovering there. You just cannot go any higher. It was so strange and so interesting. So basically, the motor and prop combination matters a lot. Specifically for this project, as the current draw is directly connected to the KV and it affects directly your sag on lithium ions, it's not the most optimal thing to do. But when you find a sweet spot, as I did with 11,500 Happy Model 12 2.5 motors, it's when everything sits into place, it's a real pleasure. And last but not least, the battery. Battery means a lot. Like, I tried 21700 battery for all of my initial flights, and the whole internet is buzzing about the Ampace or whatever, 18650 and the magic performance that it does. So I ordered a couple, also modded them and put them on BT 2.0 connector, so I can connect them directly to my AIO, and went for a couple of test flights. It's a different quad, and it performs great. It really does. It performs great for shorter flights. It performs much better in regards to agility, maneuverability, diveability. All of these things are better, but where it doesn't shine is the flight duration. The flight duration and how long can you keep the throttle up with your battery. 2000 milliamp hours difference is noticeable. Of course, the 20 grams difference is also noticeable, but when you want to, go for a record, as I did, I'm still going for, I still haven't reached the 5,000 meters distance. It matters a lot. For me, this is for my builds, is the most important part. Less weight, better flight performance, cool, but less weight in this case means a lot less capacity. Like with all, airborne appliances, energy density is the most important element of how long can you stay in the air. And when you have so much milliamp hours, 4,950 to be exact, in this 21700 that I fly, it shows. So within this flight that you are seeing, the Ampace already went home. It was drained to 2.8 volts. And now with the 21700, I'm still trying, to really spend as much milliamp hours as I can. Regarding the milliamp hour meter configuration or the calibration, I did the calibration of both batteries separately. They both, how you just fly, you notice what your OSD shows, and after you land and charge the battery back again, you know what does the charger say and how many milliamp hours did it pour back into the battery. And if the difference is like more than 1 or 2, 3, 4, 5%, you can adjust further, but I settled it just like maybe less than 1% of difference is shown. And after spending 4,000 milliamp hours with this battery, I decided to call it quits as the voltage got to me and the battery sagged to 2.8. So basically what we did this flight. I went 4 kilometers out, turned back, went another kilometer out and back again. So that's 10, the one that I'm aiming for, and then just cruised around and wanted to spend the battery. This flight really showed me that DJI O4 was the proper choice, because even 4 kilometers out with some I would say minor with some minor deficiency, with some minor drops under 10 megabits. So 4 kilometers out you are still above 15-20 megabits of stream data back to you. So it's really great. Potentially in a less congested environment it would be even better, with less Wi-Fi and yeah. So I really love the small Ranger build. It taught me so much about drones, about flying, about prep, about checking, pre-flight checks and flight configuration and stuff like that. And it made me a better builder, because it's such a small and tight board. I really think I pulled what can be pulled from it. I'm still amazed that such a small board, 3-in-1, can pull this off, and you can fly like 20 minutes and 10 minutes out and 10 minutes back with this with no major issues. Even like I had the throttle output limit or motor output limit set on this quad for battery conservation purposes. Now it's been removed, and now it can even go much faster. I mean, it's not like much faster, but the difference between 20 and 30 kilometers per hour for cruise speed to go further is a lot. And without that big expenditure. Of course, when you reduce the motor output limit, you get some correction deficiencies there, but it's not the point of this exercise. The point of this exercise was to go as far out as possible. And I think I did it. So thank you everybody for chiming in. Thank you everybody for joining and actually listening to my gibberish about flying small drones. I really love them. I'm gonna keep flying them. And yeah, see you in the next one.